Hey guys, so here's part 2 of the day 1. We're now going to be talking about box plots. So let's talk about the shape of it, okay? So basically you have these branches, and then in the middle is our box, okay? These are going to be represented by certain statistics. Our first branch, a little part here, that's going to be represented as our minimum value. So using our box that we have, because below is the box plot of the same data that we've already dealt with the summary statistics. Basically, we have a minimum of 3, okay? Then the next part we build is going to represent our Q1. Now you might be wondering, what is Q1? That means quartile 1. Okay. And we said that is about 4 there. Okay, from there we have the middle, which we call the median. And our median is 10, so you can see that is right on that 10 spot there. And then our next point we have is our Q3, so that's quartile 3, and that's going to be 21. Now basically what this is saying is you have the lowest amount, and then in your lower half of the data points, you have the quartile 1. Then of your entire data points, you have the median, so the middle number. Then you have what is called the upper values, and that's where you can find Q3. And then lastly, we have our max value, which is at 35. Okay. I'm going to re-explain what that all is with number sets, because it's going to be a lot easier when we talk about that. Okay. But just know, when we are creating a box plot, you do need to have an interval, so you know. Or another way is kind of just to show like what's your min, what's your Q1, median, Q3, and max. Okay. Now for each part, what we have is going to represent 25% of your data. So from our minimum value to our Q1, that's going to represent 25% of our data. From Q1 to our median, we have another 25% of our data. The median to our Q3, that's another 25%. And then Q3 to our max is another 25%. So the thing is, what you can look at is if our box plot is very short, that means a lot of your data is very close together. If it's a little bit longer, that means, data points are a little bit spread apart. Especially we can see that with the Q3 to max. We can see that, we have data that's a little bit spread out apart, so we might just have a couple that is in between the Q3 and our max, okay? Okay, so now we kind of know how to build this. Let's go ahead and talk about how to find all these values. Now range, we should already know. You take the maximum value, subtract from the minimum, you figure out the entire range of your data points. Okay, Q1, that's going to be the median. So remember, that means middle of lower half. And when I mean lower half, I mean lower half of your data points. And then Q3 is the median of the upper half. And that's the upper half of your data points. IQR, that represents interquartile range. So inter, and this is one word, but I don't have room. So interquartile, that's actually one word, and then you have range. Sorry about that, guys. So basically what you're doing is you're doing your Q3 minus Q1. Basically the idea is you're figuring out the middle 50% of your data. Okay, now let's go ahead and talk about how do we calculate Q1 and Q3. So let's first talk about when we have an odd amount of data points. So I'm going to first talk about when we have like 1, 2, 3, 4, 5, okay? Well, when we have an odd amount, we know whatever is the middle number, that's going to be our median. Now, when we do that, we get rid of it, and it's not going to be part of when we're trying to figure out our Q1 and Q3. All the values below our median, that is what we call the lower half. It's the lower amount of our data points. So in this case, we have 1 and 2. Well, 4 and 5, that's going to be the upper half of our data points. Now to find here, because notice we have an even amount of numbers in our lower and upper half. So Q1 is going to be the median. So remember, in order to find the median, it needs to be in the middle of all of your data points. So the middle of 1 and 2, what we have to do is actually take the two middle numbers and add them together and divide by 2. That's how we would find the median of our lower half. And that's going to be represented as our Q1. So here we do 1 divided by 2, or sorry, 1 plus 2 gives us 3 divided by 2, that gives us 1.5. So our Q1, or quartile 1, first quartile you can also say, is 1.5. Now with the 4 and 5 we do the same thing. So anytime you have an even amount of data points, you take the two middle values and add them up and divide by 2. So in this case, we would take 4 and 5, add them up to give us 9, divide by 2, that gives us 4.5. Okay. Now let's talk about if we had an even amount of data points. So 1, 2, 3, 4, 5, 6. Okay, so we split our data points, half on the other, half on the upper side. In that middle is going to be our median. Now how do we figure out this median? Well, as we did with our Q1 and Q3, we're going to take the two inner values, which is 3 and 4, add them together and divide by 2. So what that's going to give us is 7 divided by 2 is 3.5. So our median is 3.5. Now we take our lower half, so that's 1, 2, and 3. That's our lower half of the points. And then we have our upper half, 4, 5, 6. Now in this case, it's a little bit easier to find our Q1 because it's going to be the middle number. So in our lower half, the middle number is 2, that's our Q1. In our upper half, the middle number is 5, so that's our Q3. So that's how you figure out your quartile 1, quartile 3, as well as your median if you have an even or odd amount of data points. Okay? Okay, so now the next thing we're going to talk about is outliers. Okay, so an outlier is a data value that is either way too small or way too big, okay? Now, how do we figure out if a data point is an outlier? Well, we have our upper limit and our lower limit, okay? And this is how we can figure it out. So we take our third quartile and do plus 1.5 times the interquartile range, okay? So you use that formula, and whatever number you get, if there are any data points above it, that's an outlier. But what about the lower half, or lower limit? If we take our first quartile and subtract it from 1.5, our interquartile range, you get a number, and then any data points below that number, that is too an outlier. Okay? So let's look at our first one. We see, are there any outliers in the following data set? Okay, well, the first thing is we got to figure out the median and then figure out our first quartile and third quartile. So it looks like everything is already ordered in chronological order, so we're good to go. Now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got an even amount, so I need to do 5 for my lower, 5 for my upper. Now, sometimes you can look at a set of data and probably tell what the outlier is, but if you're not quite sure, you can still use this formula to help you. Okay, so our median is in that middle part in between 22 and 29. We don't really need to calculate it because it doesn't really help us find the outlier. But in our lower half, we have, lovely, an odd amount. So 14 is our Q1, and it looks like in our upper half, Q3 is going to be 36. Okay, so let's figure out our upper and lower limits, and we do need to figure out our IQR. So remember IQR, we do that by taking our Q3 minus our Q1. So we have 36 minus 14, and we do that, we get 22, okay? Okay, so now upper limit, we do 36, because that's our Q3, plus 1.5 times 22. You can plug that into your calculator, you get 69. Lower limit. So we take our Q1, which is 14, minus 1.5 times 22, and that gives us negative 19. So let's see, in our data points, do we see any values that are smaller than negative 19? No, so we're kind of good to go there. Okay, but what about above our upper limit of 69? Yes, we see this 70 here. So 70 is an outlier. Okay, so you might say, why might an outlier occur? Well, go ahead and pause the video and maybe think of why we would have an outlier. Okay, well, here are some ways. Error in recording or measurement, that is an idea there. Sometimes we make errors, okay? It could be by chance. Sometimes you just get something that's either too high or too low. It happens. And sometimes it's not in the defined population. So there could be plenty of different ways or different reasons why we might get an outlier. Okay, make sure you guys watch part 3 of these day 1 notes. We're going to be talking about another measure of spread called standard deviation.